It is, according to its manufacturer, the largest press of its kind in the world. It stands nearly 60 feet from its base below floor level to the top of its crown, and it weighs more than 3 million pounds. Able to exert 4,800 tons of pressure on a steel sheet, this giant stamps out an entire side of an automobile in one operation. Yet it is designed for precision and built to meet exacting tolerances. When Honda of America planned the installation of a 4,800-ton transfer press at its automobile factory in Marysville, Ohio, it set in motion an army of men and machines on both sides of the Pacific Ocean. To design and build the press, Honda selected Hitachi Zosen of Osaka, Japan. To assemble and erect the press, as well as to install the necessary electrical and mechanical systems, Honda chose Atlas Industrial Contractors of Columbus, Ohio. More than 30 years ago, Atlas began as a mover and rigger of heavy machinery. As the company grew, it added to its capabilities. Today, Atlas's expertise includes millwrighting, fabricating, machining, mechanical contracting, electrical contracting, and the design and manufacture of conveyor systems. Honda's association with Atlas had already included installation of 8 smaller stamping presses, injection molding machines for plastics, and 3 automated robotic welding lines. Having installed items as diverse as the sculpture at the Columbus Museum of Art, Atlas was accustomed to meeting a challenge. But this challenge would be complicated by Honda's schedule. The components of the giant press would arrive with only 45 days before testing was scheduled to begin. The Hitachi 4,800-ton is a transfer press, actually 2 presses in one, using progressive dies. The raw sheets of steel are pressed 4 or 5 times during the operation. Press number 1 is smaller but more powerful. Number 2 is larger because it accomplishes 4 separate pressing operations on each piece. Like an iceberg, a substantial portion of the 4,800 is below the surface, located in a large pit beneath the factory floor. The base of the unit is made up of 2 beds. Cushions are mounted on the first bed to absorb the tremendous shock of the stamping operation. The press is also equipped with rolling bolsters which facilitate rapid changing of the dies. There are a total of 6 uprights arranged in sets of 2. The middle set is doubled, since it is shared by both presses. Mounted between the uprights are the slides, which perform the stamping operation. The slides move in runners called ways, which are pre-mounted on the uprights. The material to be pressed is steel sheets cut to size. Pressing is accomplished by compression between sets of dies. The bottom die is mounted on the rolling bolster, while the top die is fastened to the slide. Resting on top of the columns are the 2 crowns. Each contains mechanical lifting equipment that raises and lowers the slide. Both presses are powered by a single electric motor. The reciprocating action is imparted by massive eccentric gears. Atlas also installed the complex transfer system that carries parts through the press. This is operated by a series of cam drives in the pit. The sheet feeder and the unloading equipment, which are driven mechanically, complete the system. As we've seen, the Hitachi 4,800-ton transfer press employs a complex mechanical system including hydraulics, pneumatics, and electrical controls. Completing the installation tested the limits of Atlas's comprehensive capabilities. In addition to the moving, rigging, and millwrighting of heavy components, Atlas Mechanical Contractors installed the piping system, while Atlas Industrial Electric Company wired the complex control system. Additional support was provided by Atlas's fabricating and machine shop and conveyor division. This comprehensive approach afforded total integration of all activities on the job site, resulting in improved efficiency, performance, and safety. Much of the engineering for the press was done by Honda, while Hitachi did the fabrication in Japan. Test assembly was in this gigantic building located on the waterfront of Osaka Bay. Inside, there was ample room for the assembly of a number of presses, including this one for General Motors. Atlas's personnel went to Osaka to observe the disassembly of the press. They arrived at Hitachi's Sakurajima works as final testing was being completed. Since there was no pit in the factory floor, the press was suspended on stilts, and one had to look far overhead to see where floor level would one day be. After testing was complete, disassembly began, and Atlas's engineers got to watch the job they would soon be doing in reverse. However, the job would have to be accomplished without Hitachi's specialized cranes and the enormous amount of headroom in their plant. Starting at the top, all the components were removed, leaving the surface of the crown bare. The crowns themselves were the next to go. Atlas's engineers were especially interested in how the rigging was done. The components are loaded on trailers for transport the short distance to Osaka Bay. A huge crane mounted on a barge will load the press into the cargo hold of a ship. In the United States, the press will be offloaded in Baltimore and shipped to Ohio by rail and truck lines. Transporting the components from the rail siding in Marysville required the use of Atlas's custom-made multi-axle heavy hauling equipment, capable of carrying up to 250 tons. Here, the number 1 bed is suspended from Atlas's 400-ton gantry, ready to be moved into position. Bed number 2 was shipped in 2 sections that had to be assembled before installation. The 310-ton bed number 2 assembly was assembled on an 800-ton hydraulic gantry, which moves on rails. These steel I-beams were custom formed especially for this job. It took the supplier 3 rollings before the beams finally met Atlas's specifications. The assembly schedule had to overcome the resulting delay. Leveling was critical. Cold rolled steel shim pads were used to achieve a tolerance of 12 100,000ths of an inch per foot. Working with limited headroom, necessarily smaller cranes, and a severely restricted deadline required Atlas to develop alternative methods for assembling the press. Hitachi's instructions suggested setting all the columns first, then lowering the slides from above. Careful pre-planning permitted Atlas to set 2 columns, then place the slide beside them, then the next 2 columns, and so on. This procedure required setting up one of the tie rods that would later hold the crown in place, then carefully lowering the first column over it. Each slide had to be placed with extreme precision, so later it would meet properly with the ways in the columns. Hitachi had been able to install and remove the crowns with all the internal gearing in place. But Atlas decided to set the major gearing after the crown was installed. This solved 2 problems. It reduced the weight and also allowed the pipe fitters and electricians to keep working, instead of waiting for the assembly to be completed on the floor. Installing the crowns was the most critical part of the job. There was no room for error. It had to be right the first time. Here, the massive number 2 crown moves into place. It weighs 200 tons, 400,000 pounds. Notice the pins on top of the column. Makeup has to be exact, because you can't wiggle it around to make it fit. The picture may be a little crooked, but the crown was perfectly level. With the crowns in place, final assembly could begin. Installing the gearing was very time-consuming. It's an intricate process involving gears up to 10 feet in diameter. Special skill was required to place gears with only minimal headroom available. Atlas used the plant's overhead crane in combination with a conventional crane. The job progressed an inch at a time. On August 1st, Honda began their checkout procedures. Then the press came alive for its first operational test. It's the size of an apartment building, but it's made of surging steel. The installation had been completed in only 45 days. Atlas Industrial Contractors finished right on schedule. The key to the success of the project was coordination. To To meet the deadline, many operations had to be conducted simultaneously. Electricians, pipe fitters, fabricators, iron workers, and millwrights had to work together in a coordinated and cooperative manner. By thorough pre-planning, Atlas established safe and efficient procedures for each step of the installation. The proper equipment was always available, even when it had to be custom fabricated. But the most important element has remained unchanged for the past 30 years, the Atlas worker. Training, experience, and dedication make the difference. When there's a tough job to do, Atlas has the resources to do it right. The first time, and every time.